Hello, welcome to the video. In this example, we're given a table of data showing us how much money a company has made, what their revenue is, in millions of dollars for a year that is T years since 2000. So, for example, if we think about this first data value, it's been 1 year since 2000, so the year would be 2001, and their revenue has been 11, and the units there are millions of dollars. So we can see as time is increasing, the company is making more. The first thing we're asked to do in this example is to create a scattergram of the data, and then we're going to draw a linear model. So we've got our coordinate plane all set up here. To create that scattergram, we're first going to need to graph the ordered pairs that we're given. So my first ordered pair was given as 1, 11, and it's always nice to verify that the first number in your table corresponds to the first number, to your independent variable. And years here is the independent variable, and we see we put that on our horizontal axis. So these numbers 1 and 11 can be rewritten as an ordered pair, 1, 11. To graph that, I'll go to 1 on my t-axis, and then up to 11 on my r-axis, and I'm going to estimate there it's somewhere between 10 and 12. Alright, our next ordered pair we need to graph is 3, 15. So my t value, the years since 2000 are 3. My revenue, or my dependent variable, has a value of 15, so I'm going to go up and put that dot right between 14 and 16, for 15. And finally, my last value here, 6, 21. So to graph 6, 21, we're going to go over to 6 on the t-axis, and then up to the value 21 on the r-axis. There's our 3 dots. So now we've created a scattergram. The next thing we need to do is draw that linear model, which means if you're doing this by hand, you would want to get out your ruler and draw the line that connects these 3 points. We'll get a straight line to connect them here without using a ruler on the computer. Okay, so I'll put that in a different color so I can see, and I'll just want to connect those all by a straight line there. And remember, when you're drawing this out by hand, you always want to put an arrow on the straight line indicating that the evidence suggests the trend of that data would continue indefinitely. Depending on the real-life situation, that may or may not be a realistic assumption, but for our graphing purposes, we want to put an arrow on the end of the line. All right, so now let's look at the first question we've been asked here. We've been asked to predict the revenue in 2004. So the first thing I need to think about is, how does 2004 correspond to the axes on this graph? Well, 2004 is a year. I can't look up the number 2004 on the horizontal axis, so I need to first figure out how many years since 2000 is 2004. So I can think about 2004 minus 2000 gives me 4, so it's telling me I need to look up the value t equals 4. So on my horizontal axis, I look up the value t equals 4. I follow that up to my line, and then I look over to see what the corresponding r value would be, and it looks like it's landing right in between 16 and 18. So we'd estimate 17. We'd say predict the revenue in 2004. We predict 17. You always want to include your units, $17 million. It's very important to have that $1 million in there, because that's a big difference between $17 million and $17 or $17,000. The next thing we're asked to do is estimate when the revenue was 16 million. So here they're giving us a revenue value of 16, so we can think they're saying 16 equals R. So I look up 16 on my R-axis, and I go over to the line, and then I follow it down. And what I find there is the values just in between 2003 and 2004. If you're doing this question in WAMAP, it's only going to give you the option of entering a single year. You'll want to enter 2004 as your year, because we're going to interpret it meaning it, if we look at the beginning of 2003, it's not quite at 16 million, but when we got to 2004, we had reached 16 million. So we would say by 2004, the revenue had reached 16 million. So by 2004, the revenue had reached 16 million. In fact, it had exceeded 16 million. All right, and finally, we're asked, what is the r-intercept of the model? So when we think about the word intercept, we're remembering that's the place where our line or our model intersects the r-axis. So the r-axis is my vertical axis here, and we can see they're intersecting at this point here, right in between 10 and 9. So the R coordinate will be 9. It can be tempting to see that 9 and just type it in right away and think we're done. Please always remember, when you see the keyword intercept, it means our answer needs to be entered as an ordered pair with the independent variable given first and the dependent variable given second. So we've seen that the value of the dependent variable R is 9, so we can fill that in for our second coordinate. What is the value of t going to be at this point? Well, if we look down from this point, we see that we're right at 0 on the t-axis, so the t-coordinate would be 0. Something to keep in mind whenever you're writing out the coordinates of an intercept, one of the coordinates will always be 0. So if it's the r-intercept, then the r coordinate will have a non-zero value, and the other coordinate will have a 0 value. Now we need to interpret what does it mean. When we interpret what it means, we need to include both of these numbers in our answer. So we'll need to think about what does it mean for t to equal 0, and what does it mean for r to equal 9. So we can begin, if you're ever unsure how to begin, you can begin by writing out the units of the variable. So here's my t equals 0. 0 is the years since 2000. So if it's been 0 years since 2000, it's the year 2000. So we can begin by saying in the year 2000. So that's the first part of our answer. It's telling us what's happening with t. For the second part of our answer, we want to tell what's happening with r. So the units of r are revenue in millions of dollars. So we can say revenue was, and there's that $9 million. It's very important whenever you're writing out the meaning of an intercept that you include both of those components. In general, your answer for what an intercept means should have two numbers in it. One